Alrighty, so a piece of pie, please. We've had our pizza pie, which is good. Let's see if we can start this journey. So, has anybody heard of Katas? Code Katas? Code Katas? Alright, I know a few people. So the term kata is actually attributed to Dave Thomas of the Pragmatic Programmer. Has anybody heard of that book or read it? Alright, cool. I think it came back a long time ago, probably before some of you were born. But it has a second version. Somewhere in the 90s, I think. But it's a really good book talking about stuff that we're even trying to do today in the agile software development world. But in the katas, it's basically come up of, it's like an exercise where, you know, do something over and over again, and start practice and practice. Keep tuning your instrument, so to speak, and you are the instrument. There are several code challenges focused on improving skills. There's somebody from New York. Excuse me for a second. Hello? Okay, we'll send somebody down for you. Just a moment. Okay. Thank you, sir. We can switch off this important duty. I did see a camera go up, and normally I do take photos during the sessions, but it's kind of difficult, so I had to take a photo of everybody, say hi for the Happy New Year. There we go. Now, all right. Cheese. Yeah, or pizza. Yeah. Gotta get things, you gotta post things. And at SDJUG, if you're a Twitter fan, take a picture, post it up here, meeting's happening. Okay, there. So, yeah, I look at a kata, it's kind of like exercising. For me, I enjoy getting up in the morning, doing some stretches, going for a run, and then doing some isometrics and yoga. Do that on a daily basis, and you keep in shape. Same way with the coding kata. Is you code all day long, but you're solving problems, you're doing the work, you're going to meetings, you're getting distracted. It's kind of like, yeah, I walk all day at work, or I'm up and down in chairs, I take the stairs instead of the elevator, but that won't keep me in shape. It won't keep the muscles toned. I work different groups of muscles when I'm doing my exercises. Same way with the katas. You can train on the programming fundamentals, or you can focus on complex problem solving. Domains, mathematics, data structure, games, design, the list goes on. It's kind of like I did the Google stuff, and we'll get into that. Let's see. Some useful links. So make the slides available so all these links become available. And jump to the first one. Well, maybe not. Jump to the first one. There we go. Code Kata, because every experience is the only teacher. Interesting stuff. It talks about it and goes into some of the links and some of the stuff. Kata 1, supermarket, karate chop. Let's see. This is an old one. How many people have heard of Uncle Bob? Yay. Okay. He's up on Pluralsight. He redid his videos. It's really pretty good. So, and he likes the Star Trek motif, so he's good. The bowling game kata, I remember doing this one like 20 years ago too. So it's like it's been around forever. Another site, the Coding Dojo, Anagram, ARGS, Code Cracker, bowling. So you can see is that there's quite a bit up there. Here is a nice little reference I found. So basically just taking you to other places to talk about where you can practice or just take a look, and hundreds of answers. Yes. All right. Has anybody seen any other Code Katas sites? Been to some? Maybe you have a particular favorite. Does anybody do katas on a regular basis?
Code Wars is fun. Yeah, Code Wars.
Code Wars, okay, we'll get to that.
Eric Colvin, he has the top rank.
Eric,
Really? It's pretty tough to get.
Okay. Let's see. Yeah, okay, sorry, that's the one Code Wars that I didn't get to. Let's see if this will work. Why is it gonna freeze? No, there we go. All right, so Code Wars, and we'll take you into different areas, and yeah, the cost of ownership, sign or entry, or you do the login. I don't want my GitHub. I don't think I do GitHub, so I'm not going to log in.
Are you competing with people on that site? Or
Well, sort of. You get a rank.
okay.
Right. I like it because they have a lot of the katas in all the languages.
Yeah, you could do
Go
it in
through
different
and
languages.
try it.
Compare. But I think your rank is separate for each language. So I think Eric's is in Python. I'm not sure who has the top rank.
Alright, so I just sort of basically explored around. I'm not sure I did anything except for the very first one. Jump into katas. So, a strange trip to market. My languages, which is Java. That one. I don't think much changes on this
It's
side.
like 1,100 is what it's saying. 1,100 options you could go for.
Yeah. So how would I look up like, all right, just,
Oh. I don't know. You could. I'm not sure if you could search for people. Let's see.
C-R-I-C or K?
Okay.
Yeah. Okay, so, this is one, you can sign in using your GitHub, set up your own account, and just take a look around. I got the intro code, which you saw before I logged in. Everything can take place within the browser, and they do the compilation. It's kind of nice J shell. We'll do that for you now too. You can set those things up. Let's see. So, all right, I think I hit the others, Coding Dojo and the
Like coding that too. It's kind of like low. Like that Code Wars kind of has like heavyweight interface. It's a real lightweight interface.
Okay. Coding that.
It's like just a lot of problems.
Okay.
They're like you can do most of them in like a couple lines.
Oh, okay.
It's the Craigslist of coding katas.
Yeah, exactly. Exactly. I like that.
We're always looking for something free. Okay.
We don't need no CSS.
Right.
So various sites. Now, why Pi? Because I found it more interesting than what the coding katas were offering out there online. So, my wife said, shouldn't I do something more practical? That's Pi. And says, well, I threw in the pizza pie question. This is a question that we did prelude before everybody showed up. Okay, is it 2 mediums or 1 large? Which is the better deal? Anybody know? what? We have a medium box and we have a large box. And I got a tape measure.
Well, since you look at the mediums, it's like, I'm gonna go for mediums. That's for the non-mathematical answer.
So the medium is 14 inches. And, wow, really? I can't get a medium. Somebody threw the medium box away.
Those are all medium, huh?
No, these are all larges.
Oh, it's large, okay.
Yeah, large is 14. That's what I had read online. Seriously, somebody threw a medium box?
You got one medium specifically for the talk?
I got 2 mediums. Uh-oh, okay.
That's facilities of it?
Yeah, well, facility is the one. Okay, let's see.
We might just give it in the same box.
I found it. There. It is, well, the box is 12 and a half for the medium. And the large is 14 and a half. So we'll say 12 and 14, just to round numbers. Okay. So, you got 2 mediums for $9 and 1 large for $14, which is the better deal.
From the Pizza Hut perspective, it should be the large because they would save money on packaging.
Good point.
I know it.
Unexpected. Okay, let's see if I can find, there it is. Okay, so, my piece of compare calculator. Just, yes. Okay, and this is the non-test. Let's go to the test.
You don't even need pi though, right? Since you just square them and.
Well, if you're doing just strictly comparisons to it, yes. But if you want like price per square inch,
Okay.
then you do actually need, but even then, it's a relative function, so. But I threw this up there just to, I was going to print out, because in reality, the deal is 2 mediums for $9, which is $18, and you get 1 large for $14. So the area of a large compared to the area of 2 mediums, you get more on the 2 mediums. But the price per square inch is actually less on the large. So now the function becomes, it's not just 2 compared to 1, it's where do they cross paths economically. So should next month, should I buy all mediums at, each medium for $9? Or should I continue just buying larges? And where does that value happen? So this was the vague attempt to do that. And let's see if I run this guy, and hopefully it will. There we go. It does just run. Zoom. Okay, and then in the test, it is basically diameter is math pi power diameter by 2 gives you the radius square, and is it equal to the area, the computed area of pi. So all this guy does is return the area. And then the main method, which has not been completed yet, was to go through and return the area of increasing number of pizzas. That's what makes pi interesting. But this isn't about calculating areas. This is about pi. So, usage of pi. You can use pi all kinds of places. This is the cool part. How many digits do you really need of pi? 39, 40. And then you can calculate the circumference of the visible universe to within the diameter of a hydrogen atom. Think about that more. Yeah.
Wow.
Okay. And radius is about 46 billion light years. It's really big. our universe, and it's expanding every day. That's why it's 39, 40. You know, maybe in a few years it'll be 40. Eventually it'll be at 42 and then stop, because that's the magic number. All right, area of the circle. Okay, yeah, remember the pizza questions, open-ended. So your homework is, you know, maybe help me with that linear equation of when does the value per square inch meet up on quantity of mediums versus large pizzas, volume of the sphere, and then the surface area of the sphere. So, you know, pi is used out there. JPL and all their deep space exploration. This includes Voyager, the furthest man-made object that has ever been. That's the number of digits they use. So it's not a whole lot. That fits in a double, right? How big is a double? Anybody remember? And these are Code Katas. All right. More on pi. Okay, Wikipedia, pi history. Yeah, go to Wikipedia for everything. Google search, and everybody references Wikipedia, and you end up going back to Wikipedia. The number of digits for pi have been calculated through time. Now, pi itself wasn't known as pi until most recently, about 500 years ago, maybe 400. But it's been used because the circumference of the circle and that division thing, they've used it quite a bit. Here's a couple of historical footnotes. So, you know, 2000 BC, ancient Babylons, they had, you know, 1 digit of precision. And it kind of stayed that way up until Fibonacci. Everybody remember Fibonacci? Anybody in the Agile world? Story point estimating? Fibonacci series? Oh, okay, interesting. 1630, okay, 400 years ago roughly, we had 38 digits of pi. Okay, well, that's all we really need. We don't need to go any further, but yet we do. It's fun. 1748, Euler used it as Greek letter in his publication. So that's when pi became pi, the Greek letter. And so where we kind of bring it into the history book, so to speak. Everybody remember Euler equations, things like that? Yeah. So we're going back into the fundamentals when mathematics was in its, you know, Renaissance period. William Shanks, though, he was determined. He used 15 years to calculate 707 digits, of which quite a few were wrong. But, you know, it was really pretty good. He worked at it. Of course, Ferguson had a calculator, so he was a little bit quicker and proved that, you know, a few of those 700 digits were incorrect. Yeah, 620 digits. You have a calculator. Think about that one. You're doing long division math with carryover decimal notation and something. You get into equations too. But most recently, some people, using off-the-shelf computers, got over 2 trillion digits back in 2009, and then most recently 22 trillion digits.
Oh, in 100 years they're going to figure out some of those rules.
Actually, let's see, do I have the article? Yes. Let's see if this will work. No, it's not going to work. Okay. So, 2 quadrillionth digit of pi, using Nicholas C. of Yahoo used Yahoo's Hadoop cloud computing technology. Took them 23 days on their cluster of 1,000 Yahoo computers, and they were able to get the 2 quadrillion digit. So there are equations out there, formulas, algorithms now, that instead of calculating all the digits in a sequence, you can go off and calculate the one that you want. And what they do for verification, when you get into the trillions, that's what they do. They take a random sampling of digits, and if you got them all, it works. Remind me on that when we get into the pi calculator here, because there's a little story that I found out. Just to see if I can show that. Because it made the news basically, yeah, here you go, it made BBC News. There we go. The formula that turns an infinite sum into a more manageable calculation of single terms. Any math majors in here? Okay, I don't feel too bad. Yeah, the calculation would have taken 500 years on a standard PC, then 23 days. But it's actually pretty cool. Here again, what they use some of these calculations for is, you know, we don't need it in math, you don't need it in real life, but they're testing out the computers. Now, how is the performance of the new technology for, you know, cores or faster CPUs? So Intel does this, AMD. All right. Okay, so a little bit of that history. Okay, my search for pi. So here again, I'm looking at this from, I want some exercise. I was kind of unimpressed with what I found online. And then I searched for, well, I was interested in pi because it's like, yeah, 22 divided by 7, get you close. Well, how do you actually go off and calculate it more? You know, what kind of solution exists out there? So what are my requirements? So, well, I want to input the number of digits and have it spit out that number of digits. Okay. Don't want to store the result in memory because I won't have enough memory if I want to calculate 1,000,000 digits of pi. And well, could take a long time, but okay. I also want to try, you know, test-driven development. So it's on a pi calculator or the area calculator. Start it with the test. There's another class out there. I just wrote the class instead of TDD. Depends, but in this case, I wanted to try it. My approach was, okay, search the web, find some source code, see if it works, adapt the source code. In other words, cheat. Somebody else has solved this problem, and yeah, I'll discover it. I guess this gets down to individual learning of katas or how you exercise. So learning a new exercise is sometimes difficult, but you'll watch it, like if it's a physical exercise, you'll see how you do this new kind of, you know, lifting of a weight or isometric, and then you'll practice that isometric. You won't go off and say, I want to develop a new isometric, so I'm going to figure it out. Well, I'm going to go see how somebody else figured it out. So that was kind of my approach to pi. Let's see. Initial search, Stack Overflow, where else do you go? Unfortunately, there was not much useful code there. And you think about it, most of the talk on Stack Overflow is they don't want to give college kids the answers to their questions. So, you know, go research somewhere else, or here's a couple of algorithms. Wikipedia had lots of definitions and formulas, and then GitHub, very nicely, I found something. Roman Gutsy, in his learning Java expose, was able to see if this will work. Yay! I found some source code. There you go. And then what was better is some magic words in here. Realization of spigot algorithm based upon cut-the-knot or curriculum algorithms for spigot. And so that explanation, oops, Microsoft Office, would you like to open? Yeah. Okay, so that led to a spigot algorithm, a paper, okay, which is good because from there you find out more references, and then that led to the Gibbons paper. Yes, do that. Okay. And so in the research, basically, this algorithm, this guy came up quite a few times. So it seemed like, the focal point was understand what Gibbons was doing, and you'll figure out the algorithm from there. The unfortunate thing about this one is witness, for example, the following deliberately obfuscated C program. It's like, this is I found annoying, is they write in a paper doing this stuff, but he's not going to tell you the source code. And another interesting part, we'll get into that in a little bit. So, back to that, let's see. Yes, okay. But that was cool. So I had a get-go. I had an algorithm coded up in Java. I had the paper backing to it. Now I can kind of try and put two and two together. All right. So let's go ahead and see that. Of course, I gotta find the code again. There we go. So you guys in the back, let me know if you can read that stuff.
If you could increase the font a little bit.
Very good. Okay, so the eye test. Okay. All right. So, find pi to the nth digit, enter a number, and have the program return. Let's see, pi spigot Java. Run the code. And anybody, number of digits? Not over 100, please.
42.
42! You guys, my heroes. Okay, there we go. 42 came out pretty good. Put a print statement in there earlier on to make sure it was actually doing the looping. Don't know. Anybody know the number of digits of pi out to 42? Yeah, I
That's
don't.
right.
Yeah. At that, the League of American Programmers during the robotics competition, it took about a couple hours to judge everybody and add it up. So during that time frame, they had an auxiliary contest. Who could recite the most number of digits of pi? We had one boy do like 300. I was like, it's amazing. These guys are crazy. You get into a rhythm and you do it. There are pages on the net that tell you how to help you memorize pi. Okay. Remember, you only need about 40 digits. So okay. All right, so that was it. Now, the program ran. I didn't have to do much modification, but I was like, okay, what is it doing, and is it doing what I wanted it to do? So, let's revamp it. I'll call it the, my pi spigot test and my pi spigot. So taking the source code, renaming it, and now I've got what the original was, and I can compare it to I'm modifying it and go through an iterative process of doing that. Of course, the first test case was to create, and let's see if I can do this right. Came up over here, local history. There we go. All right, so just taking a look and zoom in way again. Starting with the small, let's go out pi of 50, let's create, assume not no, and then start off, calculate 4, calculate 10, calculate 32. Calculate 32 is where I thought I had done something really good, and then when I went to 50, it didn't match. And this is where the interesting things happen in the algorithm itself. So we'll go back to that one. This might be difficult to see. There we go. All right, so can you read that back there? All right. So in dissecting the code, didn't want it to just run, with the main program and spit it out to the system out, as you saw. Run a test case. So run the test case. Here's the value of pi I'm looking for. Calculate number of 4 digits or 34 digits, and then compare it as a subset of the pi equals 50. So it all starts with the calculate public string. So this is the kind of like the beginning of the math. I put in the answer of the string builder, and as I would find out later, string builder or putting stuff in as a string may or may not be the best thing. But here again, it's kind of like that learning process. And then of course, insert a decimal point. String builder is really good at that, whereas an array you would have to shift things out and do it. Other people have different answers, and here again, I'll come back to that. This is like the journey of going through and figuring stuff out. The actual meat of the problem, 2 for loops. Looping on the number of number of digits that you want, going through a very simple calculation. Invalid digit control is here again going back to the formula documentation. If you come across a 9 in a sequence of stuff, then you do a certain thing. If you come across, I believe it's a 10, you do a different thing. And this is all based upon an algorithm that somebody else developed. These spigot algorithms came out in the mid-90s. Okay. When I started the coding aspect, actually, this is where if anybody's a guru of IntelliJ and I'm doing the comparison over history, does anybody know how to look at the history?
Looks like you're looking at history. You mean like multiple or something, or what's the?
Yeah, what's on the left and what's on the right? Yeah, okay, let's.
You got current on the right, and then it's 1 at 10 p.m.
Okay.
January 8th at 10 p.m. on the left.
All right, so let's go to this one here. Okay, so at first I didn't put in the invalid digit control, and I got a precision up to about, I think it was like 30 digits. And then after that, it fell. And it just diverged off of what the norm should be. So, okay, I figured I got to put in the controls. And here again, it's then that trying to understand the algorithm versus just writing the code and taking it at face value. And since I was using a string builder to hold the information, then I had to use string builder to do manipulations. And so to change a character at a specific point, which is what they were doing, is you go forward, you calculate digits until you get to this error correcting function, and then you start storing information until you go a little bit further, and then you back up and replace those digits after you've calculated a few more into the future. And that way it's kind of a replacement algorithm for your error correction. And it works, except this one didn't work. The string value of, integer value of, string value of, answer, which is the string, builder, char at h. Okay. And, you know, it looks like a lot of stuff in there. Couldn't figure it out. Well, first off, it was like, let's see if I go. I want to get to where I basically, okay, maybe that was it. Does anybody know what happens when you don't cast a char? Or if you do cast a char to an int?
What's that extension?
So basically, if you have a char, it's actually a number. If you cast it to an int, you get that number. You don't get what the number of the char represents. So if you put 9 in there as a char, you don't get 9 as an integer. You get like
ASCII.
55. Yeah, okay, so I'm figuring this out. So I'm unwinding the stack, and let's see. I get back to really compact. Let's see this one here. Probably going to be the pink ones. There you go. And so I can see my failures when they're pink. Good. Set char h, answer char h, +1 char at 0. So I'm doing the replacement. And this works, it compiles, and everything looks fine, but the test failed. It still diverges off of what pi. In fact, this is where I said it diverged 1 digit. So when I calculated 50 and I'm taking a look at it, trying to find out why did it fail the test, it's 1 digit at around 44, and it's just not the right digit. And I could not figure it out. Well, it's because all the autoboxing casting going on here is all, it's incorrect math. You do have to do a string value of, an int value of, etc. And that was really annoying. So let's see if I did that here. Okay. Let's get up to this one. So I'm basically unwinding that stack back, and it looks like string value, integer value, string value, char h +1, so that will give you the right integer math. And then eventually it comes, well, okay, different story. I'll get to that one in a second. So this one will do the replacement. And it kind of worked, except not. So let me get to another. Testing string builder. Okay, so I was using a replace on string builder, and you know, you say I'm going to replace the character at 2, 314, assert that 4 is the character at 2, check, start 2, end 3, string 5, good to go. But if you're doing it with the last character, I want to start 2, end 2, replace with 5, I get that. And that was the problem of my pi calculator. Here's the thing, does that make sense that a replace 2, 2 would give you an appendage, basically? So, you go into string builder, see what it does. Read the documentation. And you probably can't read that back there, it's too light. So basically, it says, okay, the substring begins at start, extends to character, the index, end -1, or to the end of the sequence is no such character exists. It's removed, inserted, and the sequence will be lengthened to accommodate the specified string. So just in reading the code, it's still kind of shifty as to why it happens, but
I guess if you start and end at the same index, it's more like an insert than a replace.
that's exactly right, yes. Because of the end -1 effect, I think, is the end greater than count, and your count is, well, no, it's not, so end equals count. Start, count, length, new count, count plus length, end minus start. Will give you 0 because of the same. And then it grows it and shifts it in there. So to me, it's almost like it's a bug in Java or it's a bug in the documentation. But as far as I was trying to calculate pi, this one I can send off to the Java puzzler guys and say, hey, have you heard of this? And see if it meets their criteria for a puzzle. But it was just annoying, really. So let's go back. Yeah, and let's see. On the sequence. Of course, you all expect it to pass screen, right? So that is indeed exactly what happened. So with that, solving that problem left me with going to now the current set of stuff. I said, great, I'm not going to do that. I'm just going to set the char at, and I'll do char math. And so character 4-digit, get numeric value, add 1, then put it back in base 10, and insert that digit. And now the tests all pass, and I can calculate pi off into that magic land of 50 digits. And I actually increased it to 1,000 digits. And this is the alarm for 8 o'clock. Do you guys want to take a quick break and come back in about 5 minutes? Have some more pizza?
Sure.
Okay, we'll pause here.